I spent a large portion of my career working on JavaScript on the desktop, either for tooling or for frameworks that build it. And one of the things I might be most known for, at least in France, is this little stunt I built a couple of weeks ago where I put all of Windows 95 into an application, which is specifically Electron. Turns out you can run a virtual machine in JavaScript fairly efficiently if you care about the resources, right? So this is a full virtual machine and works well. And one of the things I learned fairly early on is that JavaScript on the desktop is a little bit like CGI. And what I mean by that is that whenever JavaScript on the desktop is noticed by people, it tends to upset the hordes, right? It tends to upset Hacker News, Reddit is angry, everyone is sort of angry. And I think the reason I compare it with CGI is because I don't think many people realize how much JavaScript actually is running on the desktop machines in various applications. So I have just 3 examples for you real quick. The first one being Battlefield 1. The user interface is built in React and TypeScript and MobX. There's about 1,000 components that render ammunition, the weapons, the whole user interface. And nobody's ever complained about JavaScript in Battlefield 1 simply because they don't really realize, right? It's just not all that present. But it turns out that user interfaces in games built with JavaScript aren't all that unique. And we heard earlier today about Minecraft. Second example, in this case, just Node.js, is the NVIDIA GeForce Experience. It's a tool that comes pre-installed on most Windows computers today, at least the ones that come with an NVIDIA GPU. And the GeForce Experience comes with Node.js. I don't actually know what they use to build the user interface, but Node.js is used for game streaming and background task orchestration and all kinds of things. And if you happen to have a Windows computer, you can probably just open up the folder where the GeForce Experience lives, and you will find a Node modules folder that sort of like proves that whole thing out. And then lastly, on the other side of the spectrum, we have the Creative Suite by Adobe, Photoshop, Premiere, Illustrator. All those tools actually ship with a full version of Chrome and Node.js for something called the Common Extension Platform. Plugins in Adobe's platform are built with Node.js and Chrome for pretty much the same reason we have Electron today. And that reason is that if you combine Chrome with Node.js, you have a really good tool for building cross-platform applications, right? It's really effective. You know about all the popular apps. We heard about a few. Slack is obviously one of them. But there's a lot of applications that you might not know about. My personal favorite is the Visual Studio Installer. The tool that installs the big Visual Studio is an Electron app, which always gives me a lot of joy as someone who used to work at Microsoft. And whenever Electron apps come up, as someone who co-maintains Electron, whenever I go anywhere and I talk about Electron, the project, the first thing that comes up is performance, right? People always want to talk about performance. That's the one thing they worry about. And performance means different things to different people, which I think is fair. The most common thing I hear about is memory, right? People are saying Electron uses too much memory, how can it use less memory? The thing I personally worry about is battery life. How can we make sure that Electron applications are just a little bit more lightweight, do less work? And then for many developers, it's actually something entirely different. It's speed. How quickly can I get a certain task done, right? Visual Studio Code, for instance, spent an insane amount of resources on making sure that Visual Studio Code launches in less than, I think, 200 milliseconds. It's very, very quick if you consider the amount of processes that are being spun up. And what I'm going to talk about real quick are 4 things that I look for when I think about performance on the desktop, just 4. And my theory is that JavaScript on the desktop, wherever you find it, whether or not that's in games or in CLI tools or in package managers or even in Electron apps, those 4 things are probably not being done. That's my theory. JavaScript could be a lot faster if we write it better. So I'm just going to go over those 4 things. The first one, I'm going to start with modules. That's the thing that worries me the most. So what you see up there is code that many of us would write. We're going to try to check whether or not the .js homepage is reachable. And this is a typical task where on a server, you would probably just go to npm, find this isReachable module, go ahead and run this code. It doesn't look like there's anything wrong with this code. But if you consider how much work is being done in the require statement, there's so much in this function. If you ever check out the module loader in Node.js, I mean, it's open source, you can just look at it. But it's a pretty big file, and it does a lot of work. We've heard this today before. Let's look at what this function actually does before you even run a single line of code. So we run this script in Node, and the first thing we do is we go to isReachable, and we look at the index.js. And that index.js also has a bunch of require statements at the very top, right? One of them being port numbers, and then you look at port numbers. And port numbers itself also has required statements at the very top. And 2 of them are JSON files. 94,000 lines of JSON that are all being parsed before you even run a single line of code. Is reachable is a good example because that particular issue has been fixed. It's been fixed in multiple ways. But this happens to so many people. They import an innocently looking module, and all of a sudden their applications are extremely slow, and they just don't know why. And one of the reasons they don't know why is because those modules do a lot of work before we even got to run any functions, right? So what can we do? Right, this is our code. The first thing we can do is we can just go and require the whole thing later. Right? It's a method, just do it later, just do it at a time where you actually need it. In this case, we are not doing any of this annoying work until the actual method is being called, which already allows the rest of the application to continue executing, delays the whole work. The thing that you should probably actually do, though, in my opinion, is not use a module at all, right? It's the most common answer. Especially if you're shipping your own version of Node.js, which is the case in Electron and is the case in many of the examples that I talked about today, you know exactly what kind of methods are available. And chances are that most people who use is reachable never worried about port numbers. That 94,000 lines of port numbers was just a list of which port is associated with which service. Most people didn't need that. And is reachable, by the way, no longer requires port numbers to begin with. So. Once you've realized that, once you've started thinking about how much work require actually is, you can go in and go a little further, right? So Node.js has V8, and V8 is a JavaScript engine. And what this JavaScript engine does is it uses just-in-time compilation. What that means is every single time you run a little JavaScript, it goes ahead, analyzes your code, and turns that into something your machine can actually execute. That is an expensive operation. That takes a decent amount of time. And in Chrome, if you keep visiting the same website today, eventually, Chrome will just stop doing that. It will just be like, I compiled this before. Let me just go and grab it real quick. I don't need to recompile it. If you're running JavaScript on the desktop, and you probably are if you're using NPM, Yarn, any of those things, you can do the same thing right there. What you see right here is the entry script for Yarn, a little cut down. And the very first thing they do is they load something, the V8 compile cache, which is a little module that basically replaces require and allows you to, at the second time you load any script, to go back to the already compiled blob. So you never pre-compile things twice. In the case of Yarn, they cut time down from about 180 milliseconds to 120, and that module is now also in Babel Core. It made Babel Core dramatically faster. And if we wanted to use it, that's what we would do. We would just require the module, don't really have to do anything else, keep doing the same work that we've done before, but, just make things a little easier all around on the code. So, long story short, whenever you run npm install, you might be making your application a lot slower. Just think about how you're spending resources at the beginning. And then the second big thing is painting. I don't think enough JavaScript developers actually think about the paint operation, like what is going on every single time we need to take web stuff and turn that into pixels. And as an example, I hope .js will forgive me, but as an example, let's look at the .js homepage, right? Just as an example. It's a great page. It's beautiful. It just would make a terrible application, and I'm going to show you why. So what you see here on the screen, there we go. What you see on the screen, every single time something flashes in green, that's a paint. That's an expensive operation. We're repainting the screen. And I want you to look at that little red number in the upper right. That is my CPU of a 2018 MacBook Pro, peaking up to 50% every now and then. And it's peaking up there even if we scroll down, because the way the animation is done at the very top, the whole page needs to be repainted every couple of seconds. Sorry, multiple times a second. And just keeping this page open will keep my CPU busy at 30%. Just not doing anything with it, just leaving it there. And my theory is that those developer tools are really, really good. And if people look at them, they will be able to build tools and websites that are a lot lighter in resources, right? This is part of Chrome DevTools. It's pretty amazing stuff. You can use it too. There's a lot of documentation about it, but my theory, and I'm not sure if I'm right, but my theory is that not enough web developers actually look at this stuff, right? Because as web developers, we weren't really taught to worry about battery impact. That's something most people don't think about. I don't know about you, but the people on my team definitely don't know what kind of battery impact a PR has, right? They just don't know. And these tools can help you do that. Now, the third piece. There we go. The third piece is Naturally speaking, not all code is equal. In native development, Electron, for instance, is mostly built with C++. In native development, it's fairly easy for us to benchmark code. It's not all that much harder in JavaScript. I just feel like as a community, all of us, including me, have less of a practice of doing it all the time. And we probably should be doing it a lot more. So in this example, I just want to get all the divs that have a certain class name, pretty common operation. And in the past, we would be using jQuery, right, in the early days. And then query selector came along, and we stopped using jQuery and used the query selector instead. In this example, obviously, this is going to be bad, right? That's why I'm showing it as an example. But it's not unique. I just want you to make up a number in your mind. How many % query selector is slower than get elements by class name? Just make up a number. It's 99%. It's a lot. By the time I've done almost 30 million get elements by class name, I haven't even run all 400,000 query select operations. And this is just one example, right? This is just one. Chances are that if I look at your code, we just benchmark a little bit of it, we can find a lot of stuff that in the latest version of Chrome is way slower than a less cool old JavaScript method, right? So I guess the lesson here is check your assumptions. Just because it's new doesn't mean it's fast. In most cases, it actually means it's pretty slow, which is sad, but that's just the way it is. And if I can just throw in a little nitpick, don't make promises out of stuff that don't need it to be promises. Promises are great, I love them, but overhead. Cut it out. And now, since we're already thinking about code and we can optimize code a little, I don't think enough people realize that Node.js is perfectly capable of running native code. And by extension, also Electron is perfectly capable of running native code. And whenever I encounter any kind of problem that can't be solved with normal JavaScript, I can very easily just go to C or C++. And obviously, the main reason I usually do that in Electron land is because I need to make some kind of syscall that I can't be making from Node.js, right? Like some dumb Win API stuff. And I very rarely actually have instances where I can't write JavaScript that is good enough to be performant. But every now and then there are cases. And in Slack, for instance, a lot of the calling, we have video calls, a lot of the calling are actually happening in native code because that's just the more performant way to do it. JavaScript does have limits, but Electron using Node.js doesn't mean you subscribe to those limits. It's perfectly fine to build 98% of your cross-platform application in JavaScript and then do the last 2% in C++, which is still a lot better than building the whole thing in C++, right? Because it's not like I like C++. I'm terrible at it. It's a foot gun. You will definitely shoot yourself in the foot. You'll lose some memory left and right. Where did this come from? But it's doable, right? And because we live in 2018, we're also not limited to C++. I personally, I don't know if this became clear, but I hate C++. It's the worst. But we have Rust now. And if you use tools like Parcel, you can literally just import a Rust file and it will figure it out. There's nothing you need to do. Frankly, you need to have the Rust tools installed. But you can literally just import the Rust method, which, by the way, looks like this. Right? This is the great method I wrote here. It's not very smart, but Rust looks pretty friendly. It is pretty friendly. And the idea is that if you have an operation you need to call many, many, many times, and it takes a long time, and because, I don't know, maybe you're doing some complex math, just do it natively. It's going to be good enough. OK, and then lastly, and that's the fourth point, and how useful that point is really depends on the application, right? It doesn't make a lot of sense for Battlefield. It doesn't make a lot of sense for, let's say, any CLI scripts, but it certainly makes a lot of sense for the applications like the NVIDIA GeForce experience or many Electron applications. And that is that if you build a website, you sort of live in this paternal state of the browser. The browser is taking care of your resources, and it's a little bit like money. If you're a website, the browser gives you just a little allowance, and it's sort of figured out that it's not giving you more allowance than you're supposed to have. But if you're a desktop application, you have free reign. You can pick all CPU cores. If you want to, you can keep the whole computer from shutting down, right? This is actually PR that landed earlier today in Electron. Someone figured out how to prevent Windows shutdowns from Electron, so that's going to be a feature soon, I guess. And that's stuff that websites don't get. But my point here is that if you're a desktop application, you're writing JavaScript for a desktop application, respect the fact that you might not be the favorite child on the computer right now, right? If the application is minimized, maybe stop polling every couple of seconds. If you have some kind of service you need to subscribe to, maybe just pause network requests until the application comes back up into view. And interestingly enough, the example I have here, document.hidden, if you're running on a Mac, Document.hidden will be true if the application is up, but like completely covered by something else, like a Finder window, which is super useful, right? You can stop animations, stop playing videos, stop doing all kinds of stuff that is expensive. You just saw the pain thing. A GIF, for instance, extremely expensive. If you're using Slack, nothing will kill your battery life quicker than uploading a 50 megabyte GIF to your colleagues for all of them to see. So that can be extremely effective. So I'm just going to summarize my 4 points real quick. The first one is think about modules, think about loading modules. And there have been so many jokes about node modules folders that are infinitely deep, but I don't think they really have to be. This is not a thing that we as JavaScript developers can't figure out. And I think the answer usually is to just use less of them. Just be a little bit more mindful, right? The next time you import request in something that is not a server application, consider that request is always a megabyte of JavaScript, which is many lines. Probably more lines than you have in your application, or I have in my application. It's a lot. And if you're just calling request.get, maybe just use fetch or something else. And the second point was just use the developer tools, figure out how often you're painting, figure out what your layout actually demands. And the third point, interestingly enough, the third point was to maybe not use JavaScript, but if you do use JavaScript, benchmark it a little, check your assumptions. And the fourth point was to respect the operating system. The operating system wants to help you, gives you all kinds of events on when to shut down and when to use a little bit less work. And we JavaScript developers should also do a little less work whenever we're not really needed to do 60 frames a second of GIF rendering at the given moment. If you ever have any trouble building a performant Electron application and you feel like it's definitely impossible to do so, please just find me on Twitter, because there surely are some use cases that shouldn't be built in Electron, but generally speaking, you can make Electron apps performant. It's definitely doable. So please just find me on Twitter if you feel like you're having a hard time. Thank you very much.